This video is brought to you by Ultium Designer. In today's episode, you will learn how to make a long-range wireless water level indicator using a waterproof ultrasonic sensor JSN SR040 or AJSR04M and a pair of these LilyGo TTGo LoRa 32 modules. TTGo LoRa 32 is 868 MHz and is based on the LoRa SX1276 chip combined with ESP32 Wi-Fi plus Bluetooth and an I2C supported 0.96 inches OLED display module. So many things on this tiny board, it's quite impressive. You don't have to do any soldering, just upload the desired code and start monitoring anything you want. When these modules are not in line of sight means when there are lots of obstacles in between, then the range is 77 meters, and when both the modules are in line of sight, then the wireless communication range is more than 1 kilometers. I practically demonstrated this in my getting started video on the LoRa 32. So if you have got any questions regarding its technical specifications, how to install the required libraries and how to write your first program, then I recommend you should watch my getting started video on the TTGo LoRa 32 module. HC-SR04 and the waterproof JSN SR040 are both popular ultrasonic sensors that are commonly used in distance measurement applications. However, there are some differences between them that may make one better choice depending on your specific needs. The HC-SR04 is a low-cost ultrasonic sensor that can measure distance from 2 cm to 4 meters with an accuracy of about 3 millimeters. It has a working voltage range of 5 volts DC and consumes very low power. The HC-SR04 is easy to use. It can be easily interfaced with microcontrollers and can be easily found in the market. The JSN SR040, on the other hand, is a more advanced ultrasonic sensor that has a longer sensing range of up to 6 meters and a high accuracy of up to 1 millimeter. It operates at a wider voltage range of 3 to 5 volts DC and has a built-in temperature compensation feature that helps to improve accuracy even in varying temperatures. However, the JSN SR040 is relatively more expensive and may be harder to find in the market. In short, if you need a low-cost ultrasonic sensor with a shorter range and don't require high accuracy, then the HC-SR04 may be a good choice. However, if you need a more advanced ultrasonic sensor with a longer range and higher accuracy, and you're willing to spend more, then the JSN SR040 could be a better option. For more technical specifications, features and applications, read my article. A few days ago, I created an IoT-based water level monitoring system using the same waterproof ultrasonic sensor. In that system, the water pump would automatically turn on and off. However, this time I don't want the water pump to automatically turn on or off. I want the control of the water pump to be in my hands and the hands of my family members, and I also don't want us to be dependent on the internet. The switch for the water pump is installed here, and next to it I can install my water level indicator or monitor. Then all the family members can check the water level in the water tank and turn the water pump on or off accordingly. So this is exactly what I'm going to do. So without any further delay, let's get started. This is the transmitter side and this is the receiver side. The 5-volt and ground wires of the waterproof ultrasonic sensor are connected to the 5-volt and ground pins on the LoRa 32 module, whereas the trigger and echo pins are connected to the GPIO pins 12 and 13 respectively. You can follow this circuit diagram. You can download this pinout diagram from the LilyGo official website. You can see the SSD1306 OLED display module SDA and SCL pins are connected to the pins 04 and 15. And the SX1276 LoRa transceiver module MOSI, SCLK, CSDI or RSD and MISO pins are connected to pins 27, 5, 18, 26, 14 and 19. All the other pins are clearly labeled. You can see the 5-volt and 3.3 volt pins are available on both sides. On the receiver side, you don't need to do anything as the LoRa and OLED display module are already wired up. Now let's go ahead and take a look at the transmitter and receiver side programming. If you already have an ESP32 board installed, then there shouldn't be any problem. You just need to install these libraries. But if you don't have an ESP32 board installed, then you need to install it first. And anyway, once you install the ESP32 board, then you can go to the tools menu, board, ESP32 Arduino, and from the boards list you can select TT-Go LoRa 32 or LED. This is the transmitter side programming and this is the receiver side programming. On both sides I'm using the same libraries which you can download from our website electronicclinic.com. Let's go ahead and take a look at the transmitter side programming. If you watch my previous videos on the LoRa 32 and IoT based water level monitoring system, then you would know how I combined the two codes. You can clearly see I'm using the same pins definitions. I'm using the same local address and destination address. If you want to monitor multiple water tanks, then you will have to use these addresses. You can watch my video on how to use multiple LoRa transmitters with a single LoRa receiver. I have added a link in the description. Now let's go to the loop function. This set of instructions is used to calculate the water level distance, and then using the map function we convert the distance information into water level percentage. Then we make a message consisting of the distance and water level percentage. You can see I'm using comma as the delimiter. It will help me in splitting the message to retrieve the distance and water level percentage values. Anyway, finally I send the message, and at the same time I also print this message on the OLED display module. Now let's go ahead and take a look at the receiver side programming. On the receiver side, we have got the same libraries and the same pins definitions, so let's go to the loop function. We simply read the packet, and then using the getValue function, we simply split the message using comma as the delimiter, and the retrieved values are stored in variables distance and water level percentage. And then finally, these values are printed on the OLED display module. GetValue function is a user-defined function, and its job is to split the message. You can select any character as the delimiter. So that's all about the programming. I have already uploaded these programs, and now let's start our practical demonstration. Ultium Designer is the world's most trusted PCB design system. Ultium Designer enables engineers to effortlessly connect with every facet of the electronics design process. Over 35 years of innovation and development focused on a truly unified design environment makes it the most widely used PCB design solution. With Ultium Designer, you can create PCB designs with an intuitive and powerful interface that connects you to every aspect of the electronics design process. Route it your way through any angle, tune for the delay, push, slide, and walk around faster than ever. Easily work together with your mechanical team and forget about the days of swapping design files. Every design change stays in sync between Ultium Designer and SolidWorks, PTC Creo, Autodesk Inventor, Autodesk Fusion 360 or Siemens NX. Interact and collaborate with mechanical designers like never before in a photorealistic 3D design environment. One of the best things about Ultium Designer is that you can share your designs with your team members using Ultium 365. They can check your design, leave comments, and if there are any issues, they can fix them from anywhere in the world. Ultium Designer also uses the world's fastest component search engine, Octopart, so you won't have any difficulty in searching for components. Links to the Ultium Designer, Ultium 365 and Octopart are given in the description. I have powered up the transmitter side using my designed 5V and 3 amps power supply, and my created for is lithium ion battery pack. This setup makes the transmitter side completely portable. You can use any 5V regulated power supply, and additionally you can also connect a lithium ion battery over here. LoRa 32 has an onboard charging circuit, so if in case there is any power failure, the communication won't be interrupted. You can also use a solar panel. All you need is to connect your solar panel to this 5V and 3 amps power supply. It can take input voltages up to 28 volts, and at the output it gives regulated 5V and 3 amps. So during the daytime it's going to use solar energy, and during the night time or cloudy weather it's going to use lithium ion battery as the power source. Since nothing is connected on the receiver side except the LoRa and OLED display module, so we can use a single cell lithium ion battery or even a cell phone charger or any other 5V power supply. Anyways, you can already see the distance and water level percentage on the receiver side. Let me move my hand in front of the ultrasonic sensor and you will see a change in the distance and water level percentage. Let's think of this bucket as the water tank and we have to measure the water level inside this tank. The ultrasonic sensor is in its place and you can see the distance and water level percentage on the display. So let's go ahead and fill this water tank. Support me on Patreon for more videos. I hope you liked today's episode. Like and share this video with your friends. See you in next episode and thanks for watching.